So here we have 2018, this is question 8, Leaving Cert Ordinary Level, and this is a question on trigonometry. So it says, the diagram shows a section of a garden divided into 3 parts. So this is the diagram that they gave us, I just drew it out. In the diagram, PR, so the length of PR is 3.3 meters, PQ, which is here, is 6.5 meters, QT, which is here, is 8 meters, and that's also equal to QS, so they're both 8 meters. And then QRP, so this angle here is a right angle, and then PQR, so PQR, this angle here, they're calling it, that's just a symbol, we usually call that alpha, and then this is here, this angle here is, we call that beta. So use the theorem of Pythagoras to find RQ, so the length of RQ, so it's going to be this length here. So I might just draw out this triangle, so I have RPQ, so this is 3.3, this is 6.5, and this here is a right angle. So in using the theorem of Pythagoras, say if I just had a general right angle triangle, say if this was ABC, the hypotenuse squared, so A squared would be equal to the sum of the square of the other 2 sides. But in this case, my hypotenuse, it's just kind of orientated differently, the triangle, but 6.5 is my hypotenuse. So say if I let this equal x for now, so then I would say 3.3 squared plus x squared is equal to 6.5 squared. And I'll be able to find x in that way. So x squared is equal to 6.5 squared minus 3.3 squared. So x is going to be equal to the square root of 6.5 squared minus 3.3 squared. So then 6.5 squared minus 3.3 squared, and then I get that x is equal to 5.6, and then they're dealing in meters, so, and then they asked me for RQ, so I let RQ equal x, so RQ is 5.6 meters. So then I'm asked to show that this alpha, so that angle here, is 31 degrees. So firstly I'm just dealing with that triangle, so the information that they gave me in the question was, so this is the angle, and they told me this is 3.3, this is 6.5, and I already figured out that RQ here is 5.6. So they want me to show that this angle here is 31 degrees. So I could use sin, cos, and tan. I could use any of my ratios. So I can memorize off my ratios, or I can look in my log tables and I can get the ratios from that. So say if I look at this triangle, the sin of any angle A is the opposite, which is A, over the hypotenuse, which is C. The cos of an angle is whatever B is, which is the adjacent, over C, which is the hypotenuse. The tan is the opposite over the adjacent. So I can use any of these ratios to get the angle. So say if I wanted to use, so say firstly, I'm going to have to label my sides, which is the opposite, which is the hypotenuse, which is the adjacent, according to this angle here. So firstly, the hypotenuse might be the easiest to label first. The hypotenuse is always going to be the longest side. It's going to be opposite the right angle. So this here is going to be the hypotenuse. Then the opposite is going to be the angle opposite the angle we're talking about. So this is the angle we're talking about. So this here is going to be the opposite. And then the adjacent will be the one that's left, and it's going to be the one that's beside it, but not the hypotenuse. So I can use any of my ratios. So say if I wanted to use tan. So tan of an angle is opposite over adjacent. So tan of my angle here is going to be opposite, which is 3.3 over adjacent, which is 5.6. So if I want to get the angle, I'm going to have to do tan inverse on my calculator, 3.3 over 5.6. So what I do is I go shift tan and then 3.3 over 5.6 and then close my bracket. So I get that my angle is equal to 30.51, and they said that my angle was 31, correct to the nearest degree, and if I'm to correct that to the nearest degree, I will get 31 degrees. So we've showed that. And then it says use the value. So I'm just going to fill in kind of what I know now. So I know now on my diagram that this is 5.6. I know that this angle here is 31 degrees. And then it said to use the value of alpha here to find the value of this beta here. Well, I can see that this here is a straight line, and the angles in any line, so say if we have a straight line, the angles all together, so say if I had a few different so say if we have a straight line and we have a few different angles in this line. So all these angles all together, I'm going to have to add up to 180 because that's a straight angle. So this angle here is going to be 180. Take away that angle. So so our angle beta is going to be 180 subtract 31, because altogether we're going to have 180 degrees in our straight angle, and we get 149 degrees. So this angle here is 149 because it's going to have to add up to 180, the straight angle. So we've done that, and then use the cosine rule to find the length of or s. Give your answer correct to the nearest meter. So we are asked to find the length of or s. So we want to find this length. So I'm going to actually make this into a separate triangle so I can it's a little bit clearer. So what they're looking for is they want the length of or s. So I'm going to have to I'm going to make this into a triangle itself. So this is s, or, and I figured out this was beta, but I figured out that was 149 degrees. I know this is 5.6, and I know this is 8. So, and I want the length of or s. So I can use the cosine rule with this information with that triangle. So I just got that information from this here. So in the cosine rule, it is also in our log tables, and it states that, say if we have a triangle A, B, C, and the lines A are opposite the angle, and then B and C. So that just says that if we want to we're going to deal with deal with 3 sides, and we're going to have an angle as well. So say the cosine rule states that if we're using A as our angle, we're going to have to put A in front. So is B squared plus C squared minus 2BC cos A. So if we're putting A as the angle in here, so if we want to get if we know A's angle, we should put the side opposite that angle in front. So say in this case, we're putting this, we're going to use this as our angle, because what we want to get is this length here. So we could call that side length Q. So we can kind of change this, or we can label them A, B, and C if we want. We could call this A, we could call this B, we could call this C, and then we could call this side A, this side C, and this side B. If you would rather, we can do whichever. So if we're going to be putting this as our angle that we know, we're going to have to put the side of it in front. So say A squared, and then we called our 2 other sides B squared and B and C, so is equal to 5.6 squared, and then plus 8 squared minus 2, so B is 5.6 and C is 8, and then cos of A, which is 149. Or A is actually, we called this angle A. So just for the purposes of using the cosine rule, so we have A squared is equal to, so I'm just going to work this out. So 5.6, if I do this first, plus 8 squared, So then I get 95.36, and then minus, so 2 by 5.6 by 8, so I get minus 89.6 cos 149. So if I want to get what a is by itself, I might just get the square root of both sides. So 95.36 minus 89.6 cos 149. So that'll be 95.36 minus 89.6 cos 149. So then I get that a is equal to 13.12, and they ask correct to the nearest meter. So this a would be 13 meters. But I let C, so I let or S equal a. So this is really or S. So I just let it equal, said a was 4S. Or S. So that's my cosine rule for that part of my question. And then I in the next part, so what I'm after getting is the length here. So I might just fill in that. So 13. And then we're told SQT. So SQT, so it's this here, is a sector of a circle whose center is Q. So this is a part of a circle, so this here is going to be the radius. Find the length of the arc TS. Give your answer in meters. So if I want to find the length of an arc, so I have a formula in my log tables to get the length of an arc. So the length of an arc, so the length is going to be the length is going to be 2 pi r over how big the angle is as it regards to the whole circle. So the length of an arc is 2 pi r, and then the angle that we have over 360, because 360 is the full rotation. But if I look here, I can see that if this is my circle, well this, so I'll just get a different. So this is my circle, this is my part of a circle, and the length I want to get is this length of my arc here. So I know my radius is 8, but I need to find out what is the size, what's the angle of the, so my radius is 8, so I need to get the size of this angle here. But I can see that this angle here and this angle, they're actually vertically opposite angles. So vertically opposite angles are kind of like this, and vertically opposite angles are equal in measure. So this angle here is also going to be 31. So now my angle is 31. So my angle is 31. So the length of my arc is going to be 2 pi by 8, and then 31 over 360. So that's going to be 16 pi by 31 over 360. So they asked me to get it correct to one decimal place, so I'm going to have to work it out. So 31 over 360, and I get 62 over 45 pi, or correct to one decimal place, I get 4.3 meters. So that's correct to one decimal place. And then I'm asked to find the area of the sector SQT. So the area, now I want to get the area of this. So I know my angle. So my angle is still going to be 31. My radius is going to be 8. And now I'm just using the area. So this was the length one. So this is the area. So the area is going to be pi r squared, and then my angle over 360. So my area is going to be equal to pi 8 squared, and then 31 over 360. So that's going to be 64 pi, and then 31 over 360. So if I want to plug that into my calculator, so 64 pi and then 31 over 360. So then I get, so 248 over 45 pi, or it says correct to one decimal place, so that would be 17.3 meters squared. So that is the area of my sector, and that is the end of that question.